Assalamu alaikum everyone. क्या हाल चाल हैं आप लोगों के? How is it going? वालेकुम सलाम. Okay, so शुरू करें? अच्छा, let me read a few questions. Sir, please, everyone. Okay, what does that mean? I don't know. Make video or circular measure concepts. I think I do have a video on circular measure concept, but चलो मैं एक और बना दूंगा. Circular measure, देखो, the thing about circular measure concepts is that concepts तो एक point पे आके ख़त्म हो जाएंगे, and you won't have much to learn conceptually. It's just that you need to solve lots of past paper questions to get an idea, to basically get a hold of, to get to be able to solve or to get an idea of what past paper questions will look like, and to prepare yourself for the exam. Basically, long story short, solve as many past paper questions as possible. हाँ, मैं extreme ज़रूर कर लूँगा, where I will classify questions as per their difficulty level, which will make it easy for you guys, inshallah. Okay, thank you. I appreciate it. Registered for M1 class. All right. I should mention that M1, S1 classes are starting from January. If you guys want to register for it, you can do that directly from the website, which is mathletebysart.com. Sir, सुबह मॉक है coordinate geometry and functions की range पे इतनी अच्छी grip नहीं है. Coordinate functions की range पे I have a video. You can do that. I mean, you can watch that. In fact, I have an entire playlist on functions, and coordinate geometry pe bhi, I'm pretty sure I have videos which you guys can watch. Okay, I appreciate that. So let's start. 68 out of 75, is that? Yeah, that's good progress. Given that, देखो, a lot of times this happens with students कि वो जब घर पे past paper solve कर रहे होते हैं, they're doing extremely well, surprisingly well, to a point that they actually end up surprising themselves. But then in the actual exam, things don't go as planned. Reason behind that is the environment. Okay, when you're doing it in the exam environment, the pressure is different. When you're solving it at home, the pressure is different. So make sure that if you're solving past papers, yearly past papers at home, you do it in an exam-like environment, meaning that you are timing yourself, number one, and you complete the paper in one sitting, and you don't look at marking scheme constantly, marking scheme or the solution constantly, okay? If you're doing all of that and that's the score that you're getting, then that's brilliant. Anyway, so let's start. These are the concepts that we're going to cover. This is going to be most likely a 1.5 hour, 2 hour stream. Okay, so we will learn how to use integration to find the equation of the curve, number one. Integration applied to a curve to find area. So ये सारी integration की applications हैं. Okay, these are the three main uses for which integration is used. Then there is indefinite integral, which was added in 2020. Okay, 2020 onwards, you will find questions related to indefinite integral. So today's date is the 12th of December, 2024. Will you be covering P2? You probably mean P3, right, Afia? Yeah, P3, inshallah, I'll start after January. Okay, I'll start P3 streams, inshallah, after January, and I'll do more close to exams. So let's understand, let's go over a bit of theory, and then we'll talk about, and then we'll do the concepts that I just mentioned. So basically, think of it this way, that in the center, okay, right in the center, you have the equation of the curve. Okay, right in the center, you have the equation of the curve. Now, when do we differentiate it? When do we integrate it? Okay, let's talk about that. So, equation of the curve, let's do a bit of a recap of differentiation as well. So, equation of curve ko jab hum differentiate karte hain, we do it for a certain purpose. What's the purpose? There are multiple purposes also. Okay, let's write them down. So, what are the reasons why we differentiate? Okay. Now, when we differentiate, and by the way, equation of the curve means y is equals to f of x. So when we differentiate, what do we get? We get either dy by dx or we get f prime of x. Okay, this is what we get. And from this, if you want to go back to the equation of the curve, we integrate. Okay, from this, if you want to go back to the equation of the curve, what do? We integrate. Now, the purpose of differentiation, let's write them down. The purpose of differentiation are plenty. We differentiate to find gradient. Okay, that's one reason. We differentiate to find out the equation of tangent and normal. We differentiate to find out the stationary value. Okay, and we differentiate to find out the maximum or minimum value, which is essentially the same thing. Okay, which is kind of the same thing. So let's write it down. So one reason why we differentiate is to find gradient. Another reason why we differentiate is to find the equation of tangent / normal. Okay, another reason why we differentiate is to find out the stationary value. And another reason why we differentiate is to find out the minimum or maximum value, which is kind of the same thing. So let's not actually write that down. Okay, so these are the reasons why we differentiate. Okay, now we further differentiate dy by dx for a certain purpose. And what's that? That is for the double derivative. Okay, we differentiate it again. Now, why do we differentiate it? We differentiate it to get d squared y upon dx squared. And the purpose of this is to find out the nature of stationary value. Okay, so this is, you can say, a summary of differentiation. Okay, we're not going to look into differentiation today. Okay, we're going to focus on integration. Now, when we have so we can see that one reason why we integrate is to find out the equation of the curve. Okay, but there are more reasons as to why we integrate. So we integrate the equation of the curve for two reasons. All right, so we integrate the equation of the curve for two reasons. What are those two reasons? One is to find out the area under the curve. So we integrate the equation of the curve again to find out the area under the curve. Okay, area under the curve. And we integrate it again, not integrate it again, but we also integrate it for another purpose, and that is to find out the volume generated. Okay, we call this solids of revolution because when we rotate a curve around the x or y axis, we get a 3D shape. Okay, so these are the reasons as to why we integrate. Okay, now let's talk about integration. Okay, let's learn integration. Let's do a few examples. There are two types of functions that we need to integrate: power functions and composite functions. Okay, as far as AS math is concerned. So we will start with learning how to integrate or integration of power functions. Can I trust that you will cover before May? Yeah, definitely. Before May, I will do plenty of live streams to cover the syllabus. Okay, integration of power functions. Now, how do we integrate a power function? Let's write that down. So if you have ax power n and you're supposed to integrate it with respect to x, so here's the standard rule. You add 1 to the power. Okay, in differentiate, we take 1 away from the power and we multiply the power by the coefficient of x. That's not what we do. Here, we add 1 to the power and we divide by the new power. And whenever we are integrating, there is this constant. Okay, we have this constant of integration, which we always add. Okay, now why do we add this? Let's have a look at that also. A lot of students just do it, but they don't really know what's the reason behind. So let's look into that. Why the plus c? Okay, so the reason why we have plus c is as follows. So let's say you have y equals to 3x squared plus 4. Now, if you differentiate this, so differentiating this will give us dy by dx, which is equal to 6x plus 0. Okay. Now, following the rules of integration, if I integrate dy by dx, okay, I should get the equation of the curve. Okay, I should get the equation of the curve because integrating dy by dx, remember, gives us the equation of the curve, which is y. So the integral of dy by dx will be equal to 6x squared divided by 2 Okay, you add 1 to the power, divide by the new power. Now notice, how do I know if we're starting from here, okay, if the story is starting from here, then how do we know what the constant is, okay? But in the process of differentiation, we lost a constant. Now when we integrate, we don't know whether there was a constant or whether there wasn't, so that's why we write a plus c, okay? And we can't go back to the original equation unless we are given a certain piece of information, which we're going to talk about in a minute. Then we can go back to the original equation. But this is the reason why we have a plus c. You can think of it this way. It's in memory of a potential constant that we might have lost in the process of differentiation. Okay, so you can think of it that way. Now, let's do some examples. Okay, so this is why we do the plus c. I'll put this on the side here. If you want to understand it, then you can. If you don't, then there's nothing to worry about. It's not like you'll be penalized or anything. Now, let's do a few examples. So let's say that we have the following. We have 12x power 3, which we are supposed to integrate with respect to x. So what are we going to do? Here's what we're going to do. We add 1 to the power, okay? We divide it by the new power, which is 4, and whenever we're integrating without limits, we do a plus c. So 12x power 4 divided by 4, that's 3x power 4 plus c, and that's the answer. Okay, let's do another example. Let's say that we have to integrate x squared minus 6x plus 7 with respect to x. Okay, so let's do it. You will notice that whenever you have an expression, there is a bracket before dx. That means you're integrating the entire expression. So how do we integrate x squared? That's going to be x cubed divided by 3 plus 6x squared divided by 2 plus 7x plus c. Okay, so let's simplify. Let's see. Let's simplify as much as we can. So x cubed upon 3, 6 upon 2 is 3, so that's 3x squared plus 7x plus c. Walaikum salam. Now let's do a slightly more complex question. So let's say that we have to integrate the following. 4 upon x power 3 with respect to x. Okay. So how do we integrate this? Here's how we integrate it. First, I like to call this rewriting it. So what we're going to do is we're going to write it in this way. Okay, we're going to write it this way. And the way that we do that is by shifting the denominator to the numerator using rules of indices. So I haven't integrated it yet. I've just written it in a certain way, which I like to call integration ready. Okay, that's what I like to call it because we've made it ready to be integrated. Now we integrate following the rules of integration. So we add 1 to the power, divide by the new power. You can do it directly or you can use your calculator. So 4x minus 3 plus 1, that's minus 2. Divided by the new power, that's minus 2 plus c. Make sure to simplify it. So we have minus 2x to the power of minus 2 plus c, or anything that's equal to it, meaning that you can also write it as minus 2 upon x squared plus c. ठीक हो गया? Let's do one more example, and then we'll look into composite functions as well. Okay, how to integrate composite functions. Now, let's say that we have the following. Let's say कि हमारे पास है थोड़ा ज़रा complicated सा example करते हैं. हाँ. Let's say we have x power 4 minus 2x plus 5, which we're integrating, divided by 2x cube. Okay. अब इसमें integration इतना मुश्किल काम नहीं है जितना इसका simplification है. Okay. मुश्किल से मतलब lengthy. Yes, we'll do concept as well as past papers. Okay, we'll do concepts and past papers both today, inshallah. So there's a lot of, this is more of an algebra question, less of an integration question. Okay, that's how calculus is. A lot of it is just algebra. You know, you're making x the subject, y the subject, and all that, simplifying and stuff like that. Only a fraction of it is the actual differentiation integration. Okay, once you've differentiated, the concept ends. Now you just have to use your algebra skills to write it a certain way or to be able to find a certain value. That's how it works. So, इसको integrate करने से पहले we'll have to make it integration ready. That means x power 4 upon 2x cube. Okay, the integral sign still remains. Why? Because we haven't integrated it yet. Minus 2x upon 2x cube plus 5 upon 2x cubed. Okay, close the bracket. This is what we're supposed to integrate with respect to x. Now we simplify this. So I'm going to take this to a fresh page because I'll run out of space. So now when we simplify it, so notice I still haven't used a concept that's related to integration yet. Okay, and I won't for the next, in the next step also. So when we simplify it, this is what it becomes. X bar 4 upon x bar 4 upon 2x cubed can be written as 1 upon 2x. Okay, or simply x upon 2. It's up to you how you want to write it. Minus 2 and 2 cancel using rules of indices. Same bases are being divided. Powers will be subtracted. So this will become x power minus 2. Plus 5 upon 2 as it is. When we shift x cubed in the numerator, it will become x power minus 3. And this is finally ready for integration. Okay, this is finally ready for integration. मैं M1 YouTube पे भी करूँगा. Yes, M1 मैं YouTube पे भी करूँगा. और my classes for M1 are also starting. So you can join that also. If you want live interaction and you want like question and answer session and past paper solutions and all that, then you can join the class. But if you think you can do it independently, then YouTube live sessions like these will be enough. Okay. So 1 upon 2, we add 1 to the power, that's going to be 2, and we'll divide it by the new power. Now be careful, we already have a denominator. So that means the new power will be multiplied with the denominator. Okay, minus x to the power minus 2 plus 1. We divide by the new power, which is also minus 1. Then plus 5 upon 2. X to the power minus 3 plus 1, that's minus 2. And we divide by the new power, which means the two denominators get multiplied. And this is what we get. And with integration, do not forget the plus c. So here's what we have. We have x bar 4 upon 4 minus plus ho jayega. X bar minus 1 minus 5 upon 4 x bar minus 2 plus c. Okay, and this is your final answer. Okay, now let's learn how to integrate composite functions. All right, and then we will learn how to find the equation of the curve and how to find the area under the curve. Okay, so let's talk about integration of composite functions. Okay, now let's first write down the standard rule and then we'll talk about, the first one was wrong. Was it? The first one was wrong. वालेकुम सलाम, किसकी बात कर रहे हैं आप अम्मार? It should be x bar minus 2. Oh yeah, it should be x power 2. Okay. I don't know, ये 4 कैसे बन गया? ठीक है. It should be x square. So yeah, thank you for pointing that out. I appreciate it. कल की stream मैंने इसलिए नहीं ली क्योंकि मुझे ज़रा कहीं जाना हो गया था. I'll reschedule it inshallah. Okay, now it's correct. Yeah, you're right. Now it's correct. It's x bar 4. ठीक है? If there's still an error, please do let me know. अब तो set है ना? Okay. Now, integration of composite function. What's a composite function? That is when you have an expression which is raised to a certain power. Okay. If you know how to differentiate it, then integration is just the opposite. So let's write down the standard rule. So if let's say you have y is equals to ax plus b, the whole thing to the power of n, and you're supposed to integrate it. So the integral of ax plus b, the whole thing power n, is done as follows. Ax plus b, as it is, you add 1 to the power. Okay, in differentiate, you would subtract. In differentiation, you would subtract. In differentiation, you'd multiply by the power. In integration, you divide by the new power. And in differentiation, you would multiply this by the differential of the expression inside the bracket. In this, we divided by the expression inside the bracket, which is a. And don't forget the plus c. Okay? Now, if you haven't understood this, that's perfectly all right because it's difficult to understand when we don't have actual values. So now let's do a few questions with actual values to see how things work. So let's say that you have the following. So here's the first example. Let's say you have 2x plus 3, the whole thing square, which you're supposed to integrate with respect to x. Now, I know that we can always expand it and integrate it, but because the power is 2 here, we can do that. But what if the power was root, or what if the power was, let's say, cube or power 4? Okay, then you can't. Now, second last step, abhi bhi kuch gadbad hai? Okay, ab to kuch gadbad nahi hai na? Ab I think it's fine. Okay, I'll just check the answer. The answer is correct. X squared upon 4 plus, yeah, the answer is correct. Now, so what do? Here's what we do. 2x plus 3, we add 1 to the power. So 2 plus 1, that's 3. We divide by the new power, which is 3. And we also divide by the differential of the expression that's inside the bracket, 2x plus 3, which will be 2. And don't forget the plus c. So finally, the answer will be 2x plus 3, the whole thing cubed, upon 3 times 2, which is equal to 6 plus c. ठीक हो गया? Let's do another example. Let's say that we have the following. Let's say we have square root of 3x plus 1. Okay, now we can't integrate this the way it is, so we'll have to first write it nicely. When I say nicely, I mean we have to make it integration ready. So write it in index form. Here it is. Okay. Now, sir, you should write dx beside the function. I've written it. I've written dx beside the function. Okay. Now, we add 1 to the power. We divide by the new power. So half plus 1 is 3 upon 2. And then we also divide by the differential of the expression that's inside the bracket. And then do not forget the plus c. Okay, so you can add a few steps over here. 3x plus 1 to the power 3 upon 2. Divided by 3 times 3 is 9. 9 upon 2 plus c. So 1 divided by 9 upon 2, that's 2 upon 9. So 2 upon 9, bracket open, 3x plus 1 to the power 3 upon 2 plus c. Okay, that's the correct answer. Acha, what yearly past papers do you recommend as final practice? Solve the recent past papers. Okay, if you're practicing for AS, then solve recent past papers, do it till 2020 first, and then do all the other variants, and then do before the papers before 2020. That's what I would recommend. Okay, now let's do some past paper questions where we learn how to find out the equation of the curve. Okay, so we've learned how to integrate. Let's understand. Let's apply what we have learned to find out the equation of the curve. Okay, that's one application of differentiation. And that is to find the equation of the curve. So I've taken out some past paper questions which we are going to solve. We're going to solve like 4 or 5 past paper questions. So just a minute. Sorry about that. So here's a past paper question. Let's see what it says. It says a curve is such that dy by dx, notice that we're given dy by dx, and we're given a point through which the curve is passing, which is 5 whole 2 upon 3. Okay, so we're going to learn step by step how to find out the equation of the curve. Okay, so first thing that we're going to do is, here's step 1. Okay, you don't have to write down the steps, okay, or you don't have to like divide it step by step, but this is the procedure that you should memorize and follow whenever you're solving a question like this. So first step that we're going to do is we're going to integrate dy by dx. Okay, and whenever we integrate dy by dx, what do we get? We get y. But the thing is, y will not just be in terms of x. It will be in terms of x and c. Okay, always. Every time you integrate, y will be in terms of x and c. Then step 2. यहाँ चलो हम साथ साथ step भी करते रहते हैं. So dy by dx, let's write it down over here. Here's dy by dx that we're given in the question, which is 8 over 3x plus 2 the whole thing square. Now we can't integrate it directly, so what we'll do is we will make it integration ready by taking the denominator to the numerator. So 3x plus 2 the whole thing power minus 2. So this is what we are now integrating, okay? And we're integrating it with respect to x. We're integrating 8 times 3x minus 2 power minus 2 with respect to x. So what happens when you integrate dy by dx? You get y. Okay, just like when you differentiate y, you get dy by dx. 8 remains as it is. 3x plus 2, we add 1 to the power, so that becomes minus 1. We divide by the new power, that means we're dividing by minus 1. And we also divide by the differential of the expression that's inside the bracket. Okay, so this is step 2, and step 1, and don't forget the plus c. Let's simplify this as much as we can. So we have minus 8 upon 3. Okay, we have minus 8 upon 3, 3x plus 2 to the power minus 1 plus c. Okay, now is this complete? No, it's not. Notice that we can't say that this is the equation of the curve for as long as we don't find the value of c. Okay, so what do we do to find out the value of c? Notice that we have how many unknowns? We have x, y, and c. We have 3 unknowns. So that means if I want to find out the value of c, I need to know the value of x and the value of y. Similar to if you were finding the equation of a straight line and you want the y-intercept, you want a point through which the line is passing so that you can replace x with x coordinate, y with y coordinate, and solve for c. So notice that it's not random that the question has given us a point through which the curve is passing. We're going to use that point. So then comes step 2. And what's the step 2? Step 2 is that you plug in the point through which the curve is passing, and what's the objective? Why are we plugging in the point through which the curve is passing? We're doing it to find c. Okay, so let's do this step. The point is 2 comma 5 whole 2 upon 3. So the point is 2 comma 5 whole 2 upon 3. Okay, so let's rewrite the equation of the curve here. Oops. Now 5 whole 2 upon 3 means 15. 15 plus 2, that's 17. So 2 comma 17 upon 3. So 17 upon 3 equals to minus 8 upon 3. 3 into 2 is 6. 6 plus 2 is 8. So 8 power minus 1 plus c. Okay. Now let's work this out. See what do we get? 17 upon 3. इधर आपने calculator use करना है. अपनी अकल ना इस्तेमाल कीजिएगा. Not that there's anything wrong with that. It's just that कि जब calculator allowed है, so we don't want to leave anything to chance. Okay, so this becomes minus 1 upon 3 plus c. Work out the value of c. 17 plus 1 is 18. 18 upon 3 is 6. Okay, so this is the answer to step 2. Then comes the third and the final step, which is complete the equation of the curve with the value of c. Okay, so the third and the final step is to complete the equation of the curve with the value of c. So that means y equals to minus 8 upon 3, 3x plus 2 to the power minus 1 plus 6. Okay, and there you go. This is your final answer. Okay, this is your final answer, and we have found the equation of the curve. Now, if you want, you can write 3x plus 2 in the denominator to make the power positive. There's nothing wrong with that. Make sure you read the question carefully and see what it's asking for and answer accordingly. Okay, now I'll take your questions. So I've noticed in AS past papers that every year the intensity of the questions have increased. The threshold has not gotten higher. Like I remember in 2024, was it 2024? Yeah, in 2024 the paper was relatively easy compared to what it was in 2023. 2023 the paper was extremely difficult, but then the threshold was also on the lower side. But even then, even after taking the threshold into account, I think the paper was still a difficult one. Okay, yeah, after the stream I will share this with you guys, don't worry about it. Okay, let's do another question where we learn how to find out the equation of the curve. Here it is. How much time do we have for registering for M1? You can do it till the end of December. Sir, as you will solve past paper question, will you share the worksheet? Actually, I didn't get the time to compile a worksheet. So what I will do is, once I'm done, I will share this worksheet, and as soon as I'm able to compile it, I will share it with you guys. Okay? But you guys can do it from topical past papers. I'm sure you all have a hold of topical past papers, so you can do that. How many marks in the previous question? It was 4 marks. Now, you might think it's a lot of working for 4 marks. That's because I've done it in a very elaborate way. This question, however, I'm not going to do it in a very elaborate way. Okay? But that doesn't mean that you skip steps. So we have dy by dx. Let's write that down. Dy by dx. Let's write it nicely. When I say nicely, I mean in a way that it's easy for us to integrate. Okay, now we put the integral sign on both sides. So dy by dx, when you integrate it, that's y. And when you're integrating 3x minus 4 plus 32x cubed, remember you're doing it with respect to x. Okay, so 3x minus 4 plus 1, that's minus 3. Divide by the new power, which is also minus 3. 32x power 3 plus 1, that's 4. Divide by the new power, which is 4, plus c. So y is equals to minus 1 upon x power minus 3 plus 32 upon 4, which is 8, 8x power 4 plus c. Okay, now to find out the value of c, what do we want? We want a point through which the curve is passing, and it's no coincidence. It's not a coincidence that the question has given us just that. So we're going to plug in y as 4. We're going to plug in x as 1 upon 2 to the power minus 3 plus 8 into 1 upon 2 to the power of 4 plus c. Use your calculator over here, please. Don't risk it. These are free marks that you will throw away if you're careless. So this gives us minus 8 plus 8 into 1 upon 2 bracket close to the power of 4. That's 1 upon 2 plus c. Solve this to find out the value of c, and you will get 23 upon 2. Okay, c is equals to 8 plus 4, that's 12. 12 plus half is 12.5, or you can write it as 23 upon 2. Sorry, 12 minus half, that's 11.5, or 23 upon 2. Okay, use your calculator. Now let's give the final answer. That's equal to minus x to the power minus 3 plus 8x power 4 plus 23 upon 2. Okay, this is the final answer. ठीक है, एक सवाल और करते हैं, उसके बाद we'll move on to the next concept. So here is another question, and you'll notice that questions like these are usually around 4 marks. So these are 4 easy marks if you know how to integrate. Okay, if you remember the rules of integration, these are 4 easy marks that you can get. Okay, here we go. A curve has equation y equals to f of x, and it is given that f prime of x. अब ये कोई misprint नहीं है, ठीक है, ये कोई ऐसी random सा spot नहीं है. This is f prime of x. This means that this is after differentiation. You get 2x square minus 7, and I will shift x square in the numerator in the same step so that we can integrate it easily. Now we put the integral sign on both sides. So f prime of x को integrate करेंगे, so we get f of x, which is the equation of the curve. 2x cube divided by the new power, which is 3, minus 7x divided by the new power of x, which is 1, minus 4, x power minus 2 plus 1, which is minus 1, divided by the new power, which is also minus 1, and don't forget the plus c. So we have f of x, which is equal to 2 upon 3, x cube, minus 7x, plus 4x power minus 1, plus c. Now, notice that we are given f of 1 is equals to minus 1 upon 3. That means this is x and this is y. Y, or you can say f of x. So f of 1 equals to minus 1 upon 3 means that x equals to 1, and f of x is equals to minus 1 upon 3. Okay, so we plug this in. Minus 1 upon 3 is equals to 2 upon 3, 1 cubed, minus 7 into 1, plus 4 into minus 1, plus c. So minus 1 upon 3 equals to 2 upon 3, minus 7, minus 4, plus c. Solve this for the value of c. Let's see what we get. Use your calculator as always. So you get c equals to 2. Okay. Once you have the value of c, complete the equation, and that is f of x equals to 2 upon 3 x cube minus 7x. F prime is dy by dx, yes. Minus 7x minus 4x power minus 1 plus 2. This is the equation of the curve. Okay, minus 4? What do you mean minus 4? This will become minus 4. 4 into minus 1 करेंगे तो minus 4 हो जाएगा. Achha, wait, it's not minus 1, it's plus 1. Okay, yeah, you're right. It's plus 1. So this is plus 4. Okay, thank you for pointing that out. Someone's paying attention. Sir, why did you integrate? Because we were given f prime of x and we had to find f of x. Okay, remember, if you have y or f of x and you differentiate it, okay, if you differentiate it, then what do you get? You get dy by dx or f prime of x. So that means if you want to come back to the equation of the curve, you can do so by integration. Okay, that's how it works. Now, let's move to the next concept. Okay, what's the next concept? The next concept is area under the curve. How do we use integration to find out the area under the curve? Okay, so here's how this works. Let's see. So this concept is integration to find area under the curve. Okay, how do we use integration to find area under the curve? That's what we're going to learn in this concept. Okay. Now, let's say that we have a graph. Okay. Here's the x-axis, here's the y-axis. Yeah, you can watch this for AdMaths, but AdMaths has more concepts actually, which we don't in AS. But you can watch this for AdMaths. You'll at least get a basic idea. Now, let's say that we are supposed to find the area that's bounded by, okay, we're supposed to find the area that is bounded by the following. The line x equals to a, okay, the line x equals to b, the curve, and the x-axis. So that basically means that we're talking about which area? We're talking about this area. Okay, this is the area that we are talking about. एरिया ऑफ द शेडेड रीजन. ठीक है, इस एरिया के बारे में हम बात कर रहे हैं. अच्छा, अब कैसे निकालेंगे एरिया? लेट्स सी. So here is what we are going to do. The question is that we have to find what? Find the area bounded by, and the curve that we're looking at is y equals to f of x. Okay, the curve that we're looking at is y equals to f of x. So we have to find out the area that's bounded by f of x, okay, the curve y equals to f of x. Okay, but that's not it. The line x equals to a, okay, the line x equals to b, and the x-axis. Okay, and the x-axis. So how do we do that? How do we answer this question? Here's what we do. So we integrate, okay, the area under the curve, the area under the curve is found by integrating with respect to x within the limits. Okay, so that means if I want to find out the area under this curve within the limits, I will integrate f of x. What are the limits that I will use? The upper limit is the greater value of x, which is b. The lower limit is the lesser value of x, which is a. Okay. And As a result, let's suppose, okay, so we're going to make an assumption. So we have to differentiate between, now I don't mean the mathematical differentiate, I mean the English wala differentiate. We have to differentiate between the equation of the curve and the equation that we get after integrating it. So here's how we're making that distinction. Let's say that after we integrate f of x, the equation that we get is capital F of x. Okay, so this is how we're trying to differentiate. Now we'll talk about what we mean by this. Don't worry about it. So after you've done integrating it, this is what you're going to do. You're going to get an equation in which you're going to plug in the upper limit and you're going to plug in the lower limit. Okay, which means that you will first find out f of a minus f of b, and whatever you get as a result, that is basically your area under the curve. Now I know a lot of you may not fully understand what I've done here, but don't worry about it. I'll explain. You'll understand how this works when we do an actual example question, okay? So we'll do some basic questions from the book and then we'll do some questions from past papers. But understand this, that this is the line x equals to a, okay? This is representing the line x equals to a, and we also call this our lower limit. The upper limit is representing the other vertical line x equals to b, and we also call this the upper limit. Okay, this is the equation of the curve. Okay, and this is basically with respect to x. Okay, so there are four things over here. Here's line 1, here's line 2, here's the curve, here's the x-axis. And these are the four things between which we will end up finding out the area. Okay, we'll end up finding out the area between the two vertical lines, the equation of the curve and the x-axis. Okay, let's do an example question. Like I said, we'll start off with some easy questions and gradually increase the difficulty level. Okay, so I've taken out some questions. Let's do them. Just a minute. How many topical questions should I? There is no magic number. I've talked about this multiple times. Make sure that you solve enough questions that you cover all the concepts, number 1. Number 2, make sure that you solve enough questions that you reach a point where you're not really surprised by a question. Okay, if let's say you achieve these two, then that means you're on the safe side. Okay, that means you have done enough past paper questions basically. So here's a question. Let's solve this. It's a fairly easy question. Like I said, it's a question from the book. Okay, it's not a past paper question just yet. It says find the area of the shaded region. Okay, find the area of the shaded region. So this is an example. We'll do a few examples from the book and then we'll do some past paper questions. So what area are we finding? We're finding out the area that's bounded by the curve, okay, which means we'll have to integrate y. It's also bounded by the curve and the x-axis, so that means we are integrating with respect to x. You know, we'll always be integrating with respect to x, so that's not ever going to change. What are the limits? The upper limit is 4, okay, and what is the lower limit? That's 0. Okay, what's the shaded area in between? The shaded area is in between 0 and 4, so that means this is your lower limit, this is your upper limit. Okay, now we know the rules of integration. We are integrating x cubed minus 8x squared plus 16x within the limits 0 and 4. Okay, so this is how we do it. X cubed, when you integrate it, that becomes x power 4 divided by the new power, so that's 4, minus 8x squared, when you integrate it, that becomes 8x cubed divided by the new power, which is 3, plus 16x squared divided by the new power, which is 2, and do not forget the limits are 4 and 0. Okay, the limits are 4 and 0. Now, is there anything that we need to simplify? Yes, we can simplify 16x squared upon 2. Now, also that I should mention something over here, that sometimes instead of these brackets, you will notice modulus. Okay, you'll notice this. This modulus suggests that because we're finding out area, if our answer turns out to be negative, which will be the case sometimes, we will always give it as positive because we are finding out area, and area is a scalar quantity. So let's work this out, see what we get. We get 4 power 4 divided by 4 minus 8 upon 3, 4 cubed plus 8 into 4 squared. So this is with the upper limit plugged in. Now let's plug in the lower limit. So that means 0 power 4 upon 4 minus 8 upon 3 0 cubed plus 8 into 0 squared. So when you simplify this, you get 64 upon 3. Okay, this becomes 0. So the final answer will be 64 upon 3 square units. Okay, so I repeat the step-by-step procedure. Step 1, you integrate the equation of the curve. Step 2, you plug in the upper limit and the lower limit. And step 3, you subtract the 2 and you get your answer. Okay, why are we writing square units? Because what we have found is basically area. Okay, let's do another question. Let's do this question, and this is especially helpful. Through this, we're going to understand a concept which is something that we might use in M1. Okay, this is something that you will need in M1. So let's see how this question is slightly different than the question that we have done above. Is it compulsory to write square units? I suggest that you do. Although in A levels हमें यूनिट पे पेनलाइज नहीं किया जाता, ठीक है. ओ लेवल्स में भी नहीं किया जाता था क्योंकि हमें यूनिट दिया हुआ होता था नेक्स्ट टू द आंसर, बट ए लेवल्स में हमें इस चीज़ पे इतना पेनलाइज नहीं किया जाता. ओके, नाउ वी हैव बिगर फिश टू फ्राई बेसिकली. सो वी हैव टू फाइंड आउट द एरिया अंडर द कर्व. नाउ द एरिया, the shaded area is bounded by the curve, the x-axis, the two values of x, 5 and 0. So that means we have to integrate the equation of the curve x into x minus 5 with respect to x within the limits 5 and 0. Okay, so we can't integrate this the way it is, so instead we will first expand. So this becomes x square minus 5x. This is what we're integrating within the limits 0 and 5. Now notice something interesting will happen here. So we have x cube upon 3 minus 5x square upon 2. Okay, and we will apply the limits 5 and 0. So let's plug in the limits. Let's plug in 5 in the equation of the curve. So that's 5 cube upon 3 minus 5 into 5 square upon 2. Okay, so this is with the upper limit plugged in. Now let's plug in the lower limit. Let's see what happens. Now when you plug in the lower limit, everything just becomes 0. Okay, 0 cube upon 3 minus 5 into 2 into 0 squared. Now you'll notice that the answer that you get is minus 125 upon 6. Okay, the answer that you get is minus 125 upon 6 square units. Now this minus is trying to tell us something. Okay, this minus is trying to tell us something. What is this minus trying to tell us? This minus is trying to tell us that the area is actually below the x-axis. Okay, the area that we have found is actually below the x-axis. Here we can see that yes, the area is actually below the x-axis. लेकिन ये माइनस हमें ये बताने की कोशिश कर रहा है कि अगर हमारे पास ग्राफ नहीं बना हुआ तो हमें पता चल जाए माइनस साइन देख के that the area is below the x-axis. Okay, but the final answer that we will write is 125 upon 6. Okay, 125 upon 6 square units. Okay, अच्छा मैं ये नोट भी लिख देता हूँ, then I'll take your questions. Note, if the area is below the x-axis, then the answer after applying limits will come out to be negative. ठीक है, ये याद रखना. Okay, so please एक thumbs up दिखा दें. अच्छा, उससे क्या होगा? Is it I am lost in the step 2? अच्छा, I'll just give you guys a summary of it. So the summary is as follows. First, you identify that the area that we have to find, what is it bounded by? So you can see it's bounded by the curve, it's bounded by the x-axis and two values of x, 0 and 5. So that means we have to integrate the curve within the limits 5 and 0. Okay, within the limits 5 and 0. So first we integrate the equation of the curve. Okay, this is what we get. We get x cube upon 3 minus 5x square upon 2. Then we plug in the upper limit and then we plug in the lower limit and we subtract the 2. Okay, what you get as a result is the area, which if it's negative, that means it's below the x-axis. Do you go to the gym? Yeah, I do go to the gym. Now, और सवाल करें? Let's do some more questions. I'm on good. Okay, I doubt that's true. So let's do some past paper questions now. Past paper question is where the real learning takes place. Ahmed, beta, I'm not going to do it. So you're just wasting your time. Okay, so here's a question. Now, you'll notice that the questions that I've solved, you'd be extremely lucky if you get questions like these in past papers. Okay. You will get slightly more complicated question in past papers, but the procedure remains the same. Okay, the procedure that we use to solve them remains the same. So here's a past paper question. I think it's fairly recent as well. There will always be some extra work that you have to do. So let's see what this says. So this says the diagram shows the curve with the equation y equals to 5x power half and line with the equation y equals to 2x plus 2. Find the exact area of the shaded region which is bounded by the line and the curve. Okay. Now we have to find out area which is in between the curve and the line. Okay, it's not the area under the curve, it's area in between the curve and the line. You might think it's a difficult question, but it isn't. Okay, it might seem, but it's actually not. Okay, I mean, you should be thankful if you get a question like this. So before I can find out the area under the curve, which I will have to, okay, we need the two values of x. Okay, we need these two values. Ab dekho, in questions like these, remember planning is key. Okay, you have to plan your answer. ये नहीं कि बस आंखें बंद करके इसको सॉल्व इंटीग्रेट करना शुरू कर दिया, पता नहीं हम किसको इंटीग्रेट कर रहे हैं, क्यों कर रहे हैं. प्लानिंग इज़ वेरी इंपॉर्टेंट. ओके, अब प्लानिंग से क्या मतलब, मैं अभी बताता हूँ कि हमने प्लान कैसे करना है अपने आंसर को. अब अगर हम एरिया अंडर द कर्व निकालने, दैट्स नॉट गोना बी द आंसर. ओके, फाइंडिंग आउट द एरिया अंडर द कर्व मीन्स दैट वी हैव सम extra area as well. Okay, if I integrate the area under the curve within these two limits, then I have basically I have the entire area that's below the curve. That means from that I need to get rid of the area that is below the line. अब इसको कुछ लोग treat करेंगे as area below the line. Some people might treat this as the area of trapezium. Okay, it's up to you. It's really up to you what you want to treat it as. Okay, but this planning is very important. So let's write this down. Area of shaded region. Okay, SR is short for shaded region. ये मैं एक दफ़ा लिख देता हूँ so that I don't have to write it again and again. Area of shaded region is equal to area under the curve. Area under the curve minus the area under the line or the area of trapezium. Okay, or you can think of it as area of trapezium. Think of what trapezium am I talking about? This trapezium. One parallel line, two parallel line, okay, and it's a four-sided figure. Do Cambridge penalize for not writing dx? No, it doesn't. Okay, Cambridge doesn't penalize you on that. Now, before I can find out the area under the curve, do we have enough information? Now, see, this planning will tell you your next few steps. Okay, this planning will tell you your next few steps. You have to integrate. When we say equation of the area under the curve, meaning that you have to integrate the equation of the curve. Okay, and then you have to integrate the equation of the line, 2x plus 2. Now, both of these integrations will be integrated within the same limits, x1 and x2. But we don't have x1 and x2. So we know what our next objective is. Okay, our next objective is to find out x1 and x2. And what's x1, x2? They are your points of intersection. Okay, they are your points of intersection. Now, how do we find out points of intersection between a line and a curve? The way that we find out the point of intersection between any line and any curve, or two lines or two curves, is by solving them simultaneously. So let's say you have y is equals to 5x power half. That's the equation of the curve. Okay, and then you have the equation of the straight line, which is 2x plus 2. So we will solve these two simultaneously. If 5 marks आपको ऐसे नहीं मिलेंगे, you will have to work hard for it. So 2x plus 2 equals to 5x power half. Let's move all the terms to the left hand side. So we have 2x minus 5x power half plus 2 equals to 0. What does this look like? This is a disguised quadratic equation. Okay, so we will say that let x power half be equal to a, which means x becomes a square. So what we are solving is a quadratic equation, 2a square minus 5a plus 2 equals to 0. When you solve this using the quadratic formula or middle term breaking, it's up to you, however way you want to do it, you will get the following. You will get a equals to, let me see, you will get a equals to 2, or you will get a is equals to, I believe, 1 upon 2. Yeah. Okay, now remember, we didn't want the value of a, we wanted the value of x. So it's x power half that's equal to 2, or it's x power half that's equal to 1 upon 2. Okay, now how do we turn this to x? We do it by squaring both sides. So once you square both sides, you have one value of x, which is equal to 4. And when you square here, both sides here, you get the other value of x, which is 1 upon 4. Okay, now you can tell that the values should make sense also. You should not end up with a negative value or something like that. So here we have the two values of x. Are we supposed to show working for substitution method? It's not a lot of working, so I would suggest that you do that. Okay, I would suggest that you do that. Okay, now we have all the necessary information. Okay, we have all the necessary information to solve this question. So we know that and don't worry, you'll be given plenty of space to solve this question. So the curve that we're integrating, 5x power half, we're integrating it within the limits 1 upon 4 and 4 minus the integral of the equation of straight line with respect to x. This is also with respect to x within the limits 0 and 4. Okay? Now, sorry, not 0 and 4. Once again, same problem. 1 upon 4. This will give us the area of the shaded region. Let's start integrating the equation of the curve. That would be 5x power half plus 1 divided by the new power, which is half plus 1. Okay, and this is within the limits 4 and 1 upon 4. Minus, let's integrate the equation of the straight line. That's going to be 2x squared upon 2 plus 2x within the limits 4 and 1 upon 4. Okay, so let's simplify this a little. Let's simplify this expression inside the bracket. So this will become 5x to the power 3 upon 2, and 5 divided by 3 upon 2. Let's see what that is. That is 10 upon 3. Okay, so the simplified version becomes 10 upon 3 x to the power 3 upon 2 within the limits 4 and 1 upon 4. Okay, so let's first figure this out. Before we write down the integral of the line, let's first figure this out. So 10 upon 3, bracket open, x, which is 4. So I'm plugging in the upper limit as I speak. 10 upon 3, 4 raised to the power 3 upon 2, minus 10 upon 3, 1 upon 4 raised to the power 3 upon 2. Okay, so let's see what do we get. 10 upon 3, 4 raised to the power 3 upon 2. That gives us 80 upon 3 minus 10 upon 3 into 1 upon 4 raised to the power 3 upon 2. That gives us 5 upon 12. Okay, so let's work this out. So we get 80 divided by 3 minus 5 upon 12. That's equal to 105 upon 4. Now this is not the final answer. Okay, this is not the final answer. We have so far just found the area under the curve. Now we're supposed to find out the area under the line, which is right here. Now I'll color code this to make it easy for you guys. Okay, so 2 upon 2, that becomes 1. Okay, let's simplify this. So this will become x squared plus 2x. ब्रैकेट्स भी नॉर्मल वाले बना देते हैं. या बल्कि ब्रैकेट्स वही रहने देते हैं. Okay, now let's plug in 4. So we have 4 square plus 2 into 4, that's the upper limit plugged in. Then let's plug in the lower limit, that's 1 upon 4 squared. Okay, let's make these square brackets. Plus 2 into 1 upon 4. Okay, let's make these square brackets again. So 4 square into 2 upon 4, let's see what that is. So into 2 plus 4. 4 square plus 2 times 4, that's equal to 24 minus, let's figure this out, 1 upon 4, the whole thing squared. So bracket open, 1 upon 4, the whole thing squared, plus 2, bracket open, 1 upon 4, bracket close. So this is 24 minus 9 upon 16, which is equal to 375 upon 16. Okay, so this is equal to 375 upon 16. Now the final answer. Okay, we're almost there. This is the final stretch. 105 upon 4, which is the area under the curve, minus the area under the line, or the area of trapezium, which is 375 upon 16. Let's see, what do we get? We get 105 upon 4 minus the last answer. So we get 45 upon 16, or you can write it in mixed number form. That's entirely up to you. 2 whole 13 upon 16 square units. Okay, so 5 marks that you really had to. I wouldn't say that this was difficult, but yes, because there was a lot of working involved, because it was a lengthy one, then yes, a lot could have gone wrong. Okay, a lot could have gone wrong here. Now, any questions? If yes, let me know. If not, then let's do another question related to this concept. Now, what are your thoughts so far? Easy है? Easy है, difficult है, क्या ख्याल है? Volume इसके बाद कर रहे हैं हम. इसके बाद we're doing volume. एक क्वेश्चन इसका और करते हैं, फिर हम वॉल्यूम करेंगे. Okay. Now, next question. एक और सवाल निकालते हैं पास्ट पेपर का, इसको सॉल्व करते हैं. Here it is. Now these are 2 parts. पहला वाला part solve करना ज़रूरी है. It's very easy. It will help us in solving part 2. Basically, we need the information from the first part to solve part 2. So let's read the question. Let's see what it says. It says the diagram shows part of the curve with the equation y equals to k x cubed minus 7x squared plus 12x for some constant k. The curve intersects the line y equals to x, that's this line right here, at the origin O and at the point 2, 2. Okay. Find the value of k. Now, how do I find out the value of k? It's a 1 mark question. That means it's probably very easy. So we have y is equals to k x cubed minus 7x squared plus 12x. Okay, so this is the equation of this curve right here, this cubic curve. Now, if I can somehow find out a point through which the curve is passing, we will then be able to find out the value of k. Do we have a point through which the curve is passing? Yes, we do. We don't have 1. In fact, we have 2. But we're only going to use 1. I will not use the origin, because if I use origin, everything becomes 0. I will use a point other than origin, and that's 2, 2. So y is equals to 2, k as it is, 2 cubed minus 7 into 2 square plus 12 times 2. Let's see what do we get. So let's make nice brackets first. Okay, so 2 is equals to 2 cube minus 7 into 2 squared plus 12 times 2. That's equal to 4. Okay, interesting. So 2 is equals to 4k, which means k is equals to 1 upon 2. Okay, so that's it. That's the 1 mark that you get. Okay, then the question says, find showing all necessary working the area of the shaded region. Once again, in question like this, planning is key. Can we solve it with quadratics? You can't use quadratics over here. Okay, you can't use quadratics over here because it's you just have to plug in the value and plug in x and y and solve for k. Now this is the area that we want. Once again, planning is key over here. So let's draw a vertical line here. Okay, and the x coordinate is 2. So that means if I integrate the equation of the curve within the limits 2 and 0, I will be able to find out all this area. Then from that, I need to integrate the line within the limit 0 and 2 to get rid of this area. Okay, so this planning is very important. This planning will give you a direction. This planning will tell you what your next objective is, and you'll feel far more confident when you approach a question like this with a plan, or with a certain plan in mind. So let's integrate the equation of the curve, and notice we now know the equation of the curve. Okay, let's write it down. So we will first, to find out area of shaded region, we will first find out the area under the curve. Okay, and from that we will subtract the area under the line. Okay, so let's integrate the area under the curve. We have the equation of the curve. It's 1 upon 4 into x cube minus 7x square plus 12x, और इसको हम integrate करेंगे with respect to x within the limits 2 and 0. Okay, with respect to x within the limits 2 and 0. Now here's a suggestion. I would suggest that you take the half, okay, you take it outside. All right, so sorry, it's 1 upon 2, not 1 upon 4. You take this half outside and you write it over here. Okay, and you integrate it aram se first, then you multiply your final answer with half. So here's what we get. This half remains as it is, okay, and we have x cube upon 3 minus 7x cube divided by 3 plus 12x squared divided by 2, which I would suggest that you've reached I'm sure you've reached a certain point where you can write it down directly, that it will become 6x squared. And in this you are plugging in the limit 2 and 0. Okay, you're plugging in the limit 2 and 0. So let's work this out. So we have half, and if I plug in the upper limit, let's see what we get. So I'll do this directly in the calculator, that if you plug in the upper limit, you have 2 cube. Okay, 2 cube divided by 3 x power 4. Oh yeah, that's x power 4. Thank you for pointing that out. Thank you, I appreciate it. In fact, I'll just do it once again. So I'm going to ignore this half for a minute. Okay, I'm just going to ignore this half for a minute, and I'm just going to focus on the equation of the curve. So that's going to be x power 4 upon 4 minus 7x cube upon 3 plus 12x square upon 2, which will become 6x square. Okay, thank you once again, Amar, for pointing that out. I appreciate it. अब इसमें हम लिमिट्स लगाते हैं. क्या लिमिट लगाएंगे इसमें हम? 2 और 0. Okay, इसमें हम लिमिट लगाते हैं 2 और 0. So that means 2 power 4 upon 4 minus 7 into 2 cube upon 3 plus 6 into 2 square. ये upper limit आ गई. अब lower limit की working करने की ज़रूरत नहीं है. It's just going to be 0 because when you plug in 0 in this particular expression, everything will become 0. Okay, so now let's work this out. So we have 2 power 4 upon 4. 2 power 4 upon 4 minus 7 upon 2, bracket open, 2 cubed plus 6, bracket open, 2 squared. So we get 28 upon 3. Okay, 28 upon 3 is the area under the curve. Yes, this live stream will be uploaded. Don't worry about it. Okay. Now let's find out the area under the line. So I found out the area under the curve. Now let's find out the area under the line, for which we just have to integrate x with respect to x within the same two limits, and the limits are 2 and 0. And you can also treat it like area of triangle. It's up to you. So this becomes x square upon 2, x square upon 2 within the limits 4 and 0. So if you plug in 4, you get 4 square upon 2 minus 0, which is equal to 16 upon 2, that's 8. So what we're doing is this. We are doing the following. 28 upon 3 is the area under the curve minus the area under the line. So let's see, what do we get? We get 4 upon 3, which is, let's see if that's the correct answer. 28 divided by 3 minus 8, 4 upon 3. Wait a minute. I think I've made some calculation error. Just a second. It's supposed to be 8 upon 3. Let me just double check my working. 2 power 4 upon 4. Minus 7 upon 2. 7 upon 3. Okay, I think that's the error that I've made. 7 upon 3. Oh yeah, multiply by half. See? Half को हमने ignore किया और उस चक्कर में भूल ही गए. So this is supposed to be multiplied by half. Okay. So 28 upon 3 times half, that's 14 upon 28 upon 3 को हमने half से multiply करना था ना. हाँ. So 28 divided by 3 into 0.5. That's 14 upon 3 minus 8. नहीं, अभी भी कुछ गड़बड़ है. Just a second. My mic is mute. I don't think so. Is it? Hang on, let me check. Okay, it's not mute. Just a second. Let me see. X cube upon 4 minus 7x cube upon 3 plus 12x square upon 2. Okay, wouldn't it be... No, we're basically integrating the line y equals to x within the limits 0 and 2. Half into 2 into 2 करेंगे तो 2 आएगा. y equals to x से भी तो हमारे पास आंसर. Okay, sorry, my bad. Limits मैंने गलत ली हैं. Limits होंगी actually 2 and 0, not 4 and 0. The limits will actually be 2 and 0. Okay, so one small error and everything goes wrong. So 2 square upon 2, that's 4. 4 upon 2 is actually 4. Okay. Now half into 28 upon 3 minus 4, let's see what do we get. So 14 divided by 3 हमारा area under the curve हो गया, minus 4 करेंगे तो हमारे पास answer आ गया, which is 2 upon 3. Okay. Which is 8 upon 3. So the final answer is 8 upon 3. This is not 4, this is 2. Okay? Yeah, 2. I wrote it correctly in the calculator, but I wrote it wrong here. So 2 is the area under the curve, area under the line, and area under the curve was 28 upon 3, and this is what you get. Achha, by the way, here's a small suggestion. Yeah, 4 upon 2 is 2. Thank you for pointing that out. Here's a small suggestion, and that is that you guys can actually integrate using your calculator. Okay, so अगर मैं ये exam में कर रहा होता, यहाँ पर लोग अगर इसको exam में कर रहे हैं, so here's what I would suggest. I would suggest that you learn how to check your answer. Okay, the whole objective of this is to check your answer. So this is if you have one of these calculators, this is the key that we will be using. So integral of, what are we integrating? We are integrating half. Okay, so बाहर हम 0.5 या हम half लगा देते हैं. ठीक है. किसको integrate कर रहे हैं? हम integrate कर रहे हैं x cube. Okay, so let's write x cube. All right. Minus 7x square plus 12x. Okay, let's close the bracket. What are the limits? The limits are 0 and 2. Okay, the limits are 0 and 2. Now press the equals to sign and straight away we get the answer. Okay, use this, I repeat, use this to check your answer. Okay, only use this to check your answer, and what we get is indeed 14 upon 3. ठीक है, इससे ये होगा that you will feel far more confident about the work that you have done, and you will know exactly that you're getting, you'll know for sure that you're getting all the marks. ठीक है? Now, next concept is, the second to last concept is, yes, we did indefinite integral. Okay, you can go back and watch that. Is integration, it's this concept basically. It's integration applied to curve to find volume. ठीक है, ये वाला concept है अब जो हम कर रहे हैं. So मैं इसी को copy कर देता हूँ. I'll save some time. Now this also we will learn the step-by-step procedure. Okay, what's the step-by-step procedure? Let's write it down. Let's understand this with the help of a past paper question. Okay, so we'll learn this straight away with the help of a past paper question. It's lengthy, but at the same time it's easy. Now there are two types of volumes of revolution, okay, or solids of revolution. One is that if you rotate it about the x-axis, and the other is if you rotate it about the y-axis. So first let's talk about the x-axis. Okay, just a second. Yeah, so here is part A of this concept, where a solid is rotated about the x-axis. I am using an iPad Pro and Apple Pencil 2. Not the latest one, the one before the latest one. Okay. Now, how do we work this? Let's see. Let's read the question. Let's see what it says, and then let's solve this. The diagram shows part of the curve with equation y equals to x squared minus 2, the lines x equals to 5 and y equals to 1. The shaded area enclosed by the curve and the lines is rotated 360 degrees about the x-axis. So that means we need to find out this area when it's rotated 360 degrees about the x-axis. Okay. And we are supposed to find out, sorry, not the area, we're supposed to find out the volume obtained. Okay, we're supposed to find out the volume that is obtained. So what's the step-by-step procedure? First, let's write down the step-by-step procedure. So if you are rotating it about the x-axis, okay, if you're rotating it about the x-axis like we are over here, let's see what the step-by-step procedure is. In fact, before I do this question, first let's see what the step-by-step procedure is. Step one, okay, step one is that you make y the subject. Okay, that you make y the subject. That's your first step. Okay. Then step two is that you square the answer of step one. Okay, you square the answer of step one, meaning that you do y square. Then comes step 3, which is that you integrate, okay, which is that you integrate y square within the limits, okay, within the limits a and b. Then comes the fourth and the final step, which is that you multiply final answer by pi. Now, इन सब को summarize करने का तरीका क्या है? इन सब को summarize करने का तरीका भी देख लो. The way that we summarize everything that I've written is as follows. It's integral of y square multiplied by pi within the limits b and a with respect to x. Okay, and this gives you the volume. But you can always rewind and see what I've done. Okay, you can always go back and see what I've done. Okay, instead of asking me again and again, we did equation of the curve, we did Yeah, we did equation of the curve, integration within limits, area under the curve, and this is what we're doing now. Okay. Now, I'm going to change, actually, the question that I was solving, I'm going to change it slightly. I'm going to solve a slightly different question. Okay, so just hang in there. Okay, I found a different question. Just a minute. It's from October, November. The question that I'm going to solve is from October, November 2018, paper 1, variant 3. Here it is. So a question like this is going to carry a lot of marks. That's because it's a lot of working. So I think it would be somewhere around 5 marks. Okay, like this question over here, it's of 5 marks. That's because there's a decent amount of working that's involved. Okay, so let's read the question, see what it says. So it says, find, showing all necessary working, the volume obtained when the shaded region is rotated through 360 degrees about the x-axis. So the key point here is that it's rotated 360 degrees about the x-axis. Okay, that's what we're doing. So let's follow the step-by-step procedure. What's step 1? Step 1 is we make y the subject, which it already is, so we don't have to do anything over here. So that means we jump straight to step 2. And what's step 2? That is we square y. So that means we have to square both sides. So when we square both sides, here's what we get. Y square is equals to 4 into 3x minus 1 to the power minus 2 upon 3. Okay, this is what we get. Then comes step 3, which is, let's see what step 3 is. Integrate y square within the limits a and b. So we are going to integrate y square within the limits a and b. So that means we're integrating 4, 3x minus 1 to the power minus 2 upon 3. And what are the limits? The limits are 3. And what's this value? You can take it from here. It's 2 upon 3. That means 3 and 2 upon 3. And I'm going to bring this 4 outside. Don't forget to multiply it by 4 like we did earlier. So let's figure this out. 3x minus 1 minus 2 upon 3. We add 1 to the power. We divide by the new power. So when you add 1 to the power, it becomes 1 upon 3. And when you also divide by the differential of the expression inside the bracket, that's 3. Okay, these two cancel. And the limits that we will apply are 3 and 2 upon 3. Okay. So here's what we have. We have 3x minus 1, the whole thing to the power 1 upon 3. Within the limits 3 and 2 upon 3. Okay. So let's work this out. Use your calculator over here. No need to work it out mentally. As in, do the working in your calculator and make sure that you write it down. That's what I mean. So 3 into 3, that's 9. 9 minus 1 is 8 to the power 1 upon 3. So we get 2. This is with the upper limit plugged in. Now, wherever I've plugged in the upper limit, which is 3, I'm going to plug in the lower limit, which is 2 upon 3. So we get 1. Okay, we get 2 minus 1, which is equal to what? Which is equal to 1. Okay, so this was step 1 and 2. In fact, this was step 1. This was step 2. This was step 3. Okay, the answer to step 3 is 1. Now comes step 4, the fourth and the final step. Also, don't forget that you had 4, okay, which you had taken outside. So now the answer after we multiply it by 4, okay, after we multiply this by 4 is 4. And the final step, the fourth and the final step is that you multiply the final answer by pi. So your final answer is actually 4 pi. Okay, 4 pi cube. And there you go. That's the answer. Okay, so now let's move on and do another concept, which is when we are rotating it, about the y-axis. So this is part B of the same concept. And this concept is rotated about y-axis. Now, what are the steps that we follow over here? Step 1, When you're rotating it about y-axis, you make x the subject. Okay, what do? We make x the subject. Then step 2. Step 2 is we square the answer to step 1. Okay, we square the answer to step 1, which means that we get x square. Then step 3, we integrate x square within the limits, okay, within the limits a and b with respect to y. When you make x the subject, that means x will be in terms of y. And then step 4 is the same as above, that you multiply the final answer by pi. Okay, let's do an example question to see how this works. We have a few questions in which you have to rotate it through the y-axis also. Okay, so the question that I will solve is from October-November 2017, paper 11. Okay, I've taken it out. Just a minute. Question number 10. That's a good question. Can they sometimes ask 180 degrees? They can. And there's no... all you have to do is, if you're rotating it 360 degrees, it forms a complete solid. Okay, but if you rotate it 180 degrees, that means the solid that will be formed will be half a solid. So that's when you don't multiply it by pi, you multiply it by pi upon 2. Or in the end, you just divide your answer by 2. Okay, if you're rotating it 90 degrees, you divide your answer by 4. Okay, but sometimes it is possible that, just remember that 360 is equal to pi and everything else can be worked out accordingly. Okay, now find, showing all necessary working, the volume obtained when the shaded region is rotated 360 degrees about the x-axis. Okay. Acha, wait a minute. Sorry, ye wapas se x-axis aa gaya. I was supposed to find a question where we had to rotate it about the y-axis. Okay. So, sorry, wrong question. Just a minute. Just a minute. Y-axis ke actually questions come hai. Mostly you will find questions where you have to rotate it about the x-axis. But there is a question which we are going to solve. Don't worry. Here it is. So this question says, let's read the question. It's slightly more complicated. It says, find the volume generated when the shaded region is rotated 360 degrees about the y-axis. Okay, in this, we're not rotating the entire curve. We're only rotating the shaded region. Okay, we're only rotating this region. Okay, so that means if I just find out the volume generated by the entire curve, that this is May-June 2020. Okay, this is May-June 2020, paper 12. So that will give me, okay, if I just find out the volume that is generated by rotating the entire curve, that will give me more area than I need. Okay, how is that? I'll explain. So basically, अगर हम shaded region को rotate कर रहे हैं, तो साथ साथ ये line भी rotate हो रही है. Okay, and what happens when you rotate a line 360 degrees? What's the 3D object that's formed? A cylinder is formed. Okay, now we don't want this area. We only want the area, we only want the volume that's generated by rotating the shaded region. So here's what we're going to do. This will be treated the same way as we treat area under the curve. Okay, when the area is in between two curves, we subtract the other, so we'll treat this the same way. So the first step is that you make x the subject. Because this is 360 degrees about the y-axis, you can see it's written y. They've written y-axis in bold letters. So first step is that we make x the subject. So when we make x the subject, that's 6 upon y. Step 2, we square both sides. So when we square both sides, we have x squared, which is equal to 36 upon y squared. Then comes step 3. Okay, so this is step 1, 2, and 3. This is step 1. This is step 2. Then comes step 3, that we integrate 36y power minus 2. What are the two limits? Because we're integrating with respect to y, we will use y values as the limit. Okay, so the upper limit will be 6, the lower limit will be 2. And in the end, don't forget to multiply it by pi also. Okay, so you can combine step 3 and step 4 if you like. So 36 y raised to the power minus 1, divide by minus 1, okay, within the limits 6 and 2. So let's write this nicely. We have minus 36 upon y within the limits 6 and 2. So if you plug in the upper limit, you get minus 36 upon 6 minus the lower limit, which is minus 36 upon 2. So that's minus 6 plus 18, which is equal to 12. And then don't forget that you have to multiply it by pi also. So that is 12 pi. Okay, so 12 pi is the volume that is generated by the curve. Okay, this is the volume that's generated by the curve. Okay, but we want only the volume that's generated by the shaded region. That means we will now subtract the volume that is generated by the line. Now, what is the equation of this line? You can treat it like a cylinder, or you can do it by the equation of the line. Since it's a vertical line with with x as 1, so that means its equation will be x equals to 1. Okay, so its equation will be x equals to 1. So now we are basically going to subtract the volume that is generated by rotating this vertical line. So first we're going to square it. So x squared equals to 2. Then we're going to integrate 2 within the limits 6 and 2. So when you integrate 2 within the limits, you get 2x within the limits 6 and 2. So that's 2 times 6, the upper limit plugged in, minus 2 times 2, the lower limit plugged in. So 2 times 6 is 12. 12 minus 4, which is equal to what? Which is equal to 8. And in the end, don't forget to multiply your answer by pi. So the final answer will be 12 pi, that's the volume generated by the curve, minus 8 pi, that's the volume generated by the line, which is equal to 4 pi. And this is your answer. Okay, so what's this 8 pi? 8 pi is basically the volume that is generated by the line x equals to 1. Okay, now what we're doing is, now we're going to do indefinite integral. Okay, how'd you get x squared equals to 2? Okay, wait a minute. Okay, it's not actually going to x squared, it's actually going to be x squared equals to 1. Now, coincidentally, I got the correct answer. It's actually going to be x squared equals to 1 only. Okay, what a huge coincidence that we got the correct answer. So it's going to be 1x, that means 6 minus 2, which is equal to, no wait, we didn't get the correct answer, we got the wrong answer. 6 minus 2, that's going to be 4 pi, and it's going to be 12 pi minus 4 pi, which is equal to 8 pi. Okay, once again, thank you for pointing that out. Okay, now we're going to do indefinite integral. Now, indefinite integral is a concept that was added in 2020. Okay, you won't find questions of indefinite integral before 2020, and it's a very easy concept. There aren't a lot of questions. We're just going to do, I think, one example question, and that will be enough. Is S1 difficult? Then M1 and P1. See, I think only permutation and combination of S1 is what students generally struggle with. If you take that out, I think S1 becomes very easy. Okay, so it's only permutation and combination that students struggle with. Other than that, normal distribution, binomial distribution, they're quite straightforward. And it also varies student to student. Some students like probability, they like statistics, so they naturally enjoy S1. Some students don't, which is why it's best that they take M1. Okay, now, इसका हम एक सवाल करते हैं. Indefinite, if you know how to integrate within limits, you can do indefinite integral as well. Okay, just one question will be enough to understand how this works. Here it is. This is the last question. Is S1 syllabus lengthy then for you? No. Syllabus of both M1 and S1 are not lengthy at all. Okay, they're 2 or 6 weeks maximum. Find. Now notice that one of the limit, indefinite integral, is basically when one limit is infinity. Okay, indefinite integral is when one limit is infinity. Okay, now the way we integrate it is very simple. Here's how we do it. So let's say that we have to integrate this. Now don't worry about what the limit is. Okay, we're going to bring that into consideration, but towards the very end. Don't worry about what it is right now. So here's what we're going to do. We're going to integrate this the way that we integrate any other function. So we shift this in the numerator, the power becomes negative, and we do this so that we can integrate it. So 3x minus 2 with, we add 1 to the power, so that's plus 1. Minus 3 upon 2 plus 1 is minus 1 upon 3, and then we also multiply by the differential of the bracket, which is 3. And because this is integration within limits, we're not going to plug in, we're not going to write plus c. Okay, but we will still simplify. So minus 3 upon 2 plus 1, that's going to be 1 upon 2, sorry. That's going to be 1 upon 2. Yeah. Now, we have 3x minus 2 to the power minus 1 upon 2 divided by minus 3 upon 2. And let's write this nicely. So if we write this nicely, here's what we get. We get 1 over minus 3 upon 2. That's going to be minus 2 upon 3 within the limit 3x minus 2 to the power minus half within the limits infinity and 1. Okay, within the limits infinity and 1. Now, whenever you're working with one limit as infinity, here's what I would suggest. I would suggest that you turn this power from negative to positive. So this will be minus 2 upon 3. Okay, and I will take this in the root, in the denominator, so this becomes positive square root. Okay, within the limit infinity and 1. Okay, now think of it this way. If I plug in infinity, what happens? Minus 2 upon 3. Okay, 3 into infinity minus 2. The idea is that inside the denominator, we'll have a very large value. Okay, we'll have a value so large that we can't actually calculate it. Okay, so you can just write this as infinity. Inside the root, we will have a huge value. Let's call it infinity. And then when we plug in 1, here's what happens. Minus 2 upon 3 into square root of 3 times 1 minus 2. Okay, so imagine this. Imagine that you have minus 2 and you're dividing it by a very large value. Okay, what happens when you divide a number by an extremely large value? What do you think? When you divide a number by an extremely large value, what happens then? In the meantime, I'll work this out. This will become 2 into 3 into 1 is 3, 3 minus 2 is 1. So this will become 3. Yes, anything divided by infinity is equal to 0. Remember this. Anything divided by infinity is equal to 0. Yes, you get a value so small that it's as good as 0. Okay, so this value, okay, minus 2 upon infinity what happens to this value is that it's not equal to 0, but it approaches 0. So this approaches 0. What we're left with is 2 upon 3. Therefore, the final answer is 2 upon 3. Okay, and this will always be the case whenever you're doing indefinite integral. You will have a certain value which will approach infinity, and you will be just left with with some other constant that you get by plugging in the upper limit, and that will be your answer. Okay, एक और सवाल कर लेते हैं इसका. Just one more question, and then that would be it. It's very easy. I don't know why people make a big deal about it. It's actually a very easy concept. So here it is. So always, yes, whenever you're dividing a certain constant by infinity, the answer will be 0. So let's do this. We are integrating 2x plus 2, the whole thing square, okay, within the limits infinity and 1. So first let's integrate this the way that we integrate any other function. We add 1 to the power, divide by the new power, okay, within the limits infinity and 1. So if you plug in infinity, here's what you get. You get 2. Infinity plus 2 is meaningless, okay? It's as good as infinity. And you're even cubing it. Divided by 3. Oh, sorry, this was supposed to be minus 2. Sorry, my bad. This was supposed to be minus 2. Let's do it again. So this becomes 2x plus 2 to the power minus 2 plus 1. That's minus 1. Divide by the new power, okay? And this is within the limits infinity and 1. How did I get 2 upon 3? Simply plug in the lower limit, okay, and simplify. You will get 2 upon 3. अच्छा, अब इसको simplify करते हैं. So this becomes minus 2 over x plus 2, and the limit that we have is infinity and 1. So once again, the same thing happens over here. Minus 2 in the denominator, infinity plus 2 becomes infinity. So this is the upper limit plugged in, minus the lower limit, which is minus 2 upon 1 plus 2. Notice what happens. Minus 2 upon infinity is something that will approach 0. This becomes 2 upon 3, and coincidentally, we get the exact same answer, which is 2 upon 3. ठीक है, अब आप लोग ये standard rule ना बना लीजिएगा कि we'll always get 2 upon 3. It's just a coincidence. Okay? So, I guess that's it. Yeah, we've done all the concepts, all the necessary concepts. Now, I will encourage you guys to practice integration on your own, and hopefully you guys will not struggle with it anymore. I'll stop here. I'll ask on my Instagram what topic it is that you want me to stream next. Make sure that you tell me there. And good luck, those of you who have their exams coming. I'll see you guys, inshallah, in the next stream. And I'll upload these notes also. You'll find a link in the description where I'll upload these notes, inshallah. Okay, so take care. If you haven't liked the stream before going, please make sure you do that. And also subscribe to the channel in case you haven't done that. Is integration for AS? No, it's the basic concepts are the same, but you have integration of exponential, trigonometric, and integration leading to ln in AdMaths, but you don't in AS. Okay, that's the difference. Circular measure, I have done circular measure past paper questions. I've done circular measure concepts as well. Maybe there's a recording. I'm not sure if it's a live stream or a recording, but well, it makes no difference anymore. Do search for it. I'm pretty sure I do have it. Okay, so I'll stop here. See you guys, inshallah, in the next stream. Take care, everyone. Allah Hafiz.